Okay, there was a homework on the product and quotient rule, which was assigned last weekend, I guess, and was due earlier this week. And I forgot to make a video about it, so let's just do it now. I'm actually going to start with the very last problem, 93. I think the way this book does it is they give you these formulas and then they expect you to use them in the homework, and so then at the very end of the homework, I say to prove them, but okay, that's kind of silly, right? Let's just prove them now so then we can use them. We did secant in class, I believe, and how do we do it? Well, we use the reciprocal rule. What's the reciprocal rule? Well, I'll write it maybe over here or something. The reciprocal rule says that the derivative of the reciprocal of a function is the derivative of that function over that function squared. Okay, so if you know that, you can just reprove that, or you could also just use the quotient rule. If you can only bother to remember the quotient rule, then you can just use that. But anyway, here we go. The derivative of secant, well, if you forget this and you need to have it, then you can just tell yourself, well, secant is just 1 over cosine. So what's the derivative of 1 over cosine? Well, it's going to be negative the derivative of cosine, so opposite of, well, the derivative of cosine is negative sine over cosine squared. And so you get this, and then people usually think of this as 1 over cosine x times sine over cosine. And so this is secant x tan x. Personally, I have that memorized, but okay, there it is. What's the derivative of cosecant? Well, this is just kind of like the same thing, right? Now the derivative of cosecant, well, that's just 1 over sine. So how do I differentiate 1 over sine? Again, I will use the reciprocal rule. And so this is going to be the opposite of the derivative of sine. So cosine over sine squared. So it really is just pretty short. It is, well, it's possible. I want to keep this video kind of short, so I won't show it, but it's possible to give a derivation, to give a proof of the derivative of secant directly from the limit definition, which is kind of maybe not that much fun, but it can be done. You can also give a geometric proof of the derivative of secant, which I think is really awesome, but okay, I won't do it right now. Anyway, here we go. What is this? This can be thought of as negative 1 over sine times cosine over sine. So what is that? Negative cosecant cotan. Okay, good. Let's finish this off. What's the derivative of cotan? Well, that is, well, best to here rewrite cotan as cosine over sine, and then to use the quotient rule. So the quotient rule says that the derivative of a quotient is, well, it's the derivative of the top times the bottom minus the top, cosine, times the derivative of the bottom, which is also cosine. Did I do that right? Cotan, yeah, derivative of the top times the bottom minus the top times the derivative of the bottom. Yep. All over the bottom squared. So, yeah, what do we get up here? We get negative sine squared minus cosine squared. So if you factor out a negative from that top, then you get sine squared plus cosine squared, which is 1. So this is negative 1 over sine squared, and that's why this is negative cosecant squared. Okay, so those 3 formulas are very useful. They each take, 1 minute basically to rederive, so just got to kind of do that. Alright, that was 93. And the rest of this homework I think is pretty chill. It's just kind of like doing a lot of problems, right? So right away the homework says, okay, do these 3 problems now that you know the product rule, the quotient rule. Alright, let's go. This particular problem, okay, yeah, it says to use the product rule, but honestly, to me, this is an example of when not to use the product rule, because, well, what is cube root t? It's t to the 1/3, and so this is t to the 1/3 times t squared plus 4. Personally, what I would do here is just multiply this through, giving me t to the, well, 2 plus a third is 7/3, plus 4 times t to the 1/3. And now, no product rule is required here because I can just use the power rule twice. So the derivative of this function is 7/3 t to the 4/3, subtracting 1 from here, plus 4/3 t to the negative 2/3. And for the moment, I think I'll just leave it like that. That seems fine. Okay, good. 5. The derivative of x cubed times cosine. Okay, so this is just the simplest possible product rule situation. What is the derivative? Well, it's the derivative of the first, so 3x squared, times the second, so times cosine, plus the first, times the derivative of the second. So the derivative of cosine is negative sine. And there it is. That's the whole problem. You might want to factor out an x squared if you're into that sort of thing. So the answer becomes 3 cosine x minus x sine x. Okay, number 11 is an example of the quotient rule. So let's do that. You have to just kind of know the quotient rule. So like I said, the derivative of the top, which is cosine, times the bottom, so times x squared, minus the top times the derivative of x squared, which is 2x, all over the bottom squared. So you do get an x to the 4th down there, and you can pull an x out of the top and the bottom. So, okay, doing a little bit of algebra in my head, this is x cosine x, so x times cosine x, that is, minus 2 sine x, and it was x to the 4th down there, but now it's x cubed because I pulled an x out of the top. Okay, so that was 3, 5, 11. Many of these other ones are also pretty short and easy, so I'll be back in 1 second to do some more. Okay, we are back. Number 17 says find the derivative of this function at pi over 4. Okay, this is really just practice. So here's my function, x cosine x. How do I differentiate it? Well, derivative of the first, which is 1, times the second, cosine, plus the first times the derivative of cosine, which is negative sine. So just doing the practice. So what do we have here? Cosine x minus x sine x is the general formula. So when I plug in pi over 4, what am I going to get? Okay. Should I try to be cool here or not really? Well, okay, here you just get root 2 over 2 minus, this is pi over 4 times root 2 over 2. So maybe I'll just leave it like that. Anything deeper going on here? I don't think so. Division plus the first times, yeah, that's it. So I have my formula, I plug in pi over 4, there we go. 19, similar kind of thing. Let's go. What is the derivative in general of e to the x sine x? Well, it's the derivative of the first, so that's e to the x, times the second, so sine, plus the first, times the derivative of sine, which is cosine. And yeah, so we just get this formula, and okay, if I plug in 0, sine of 0 is 0, so that dies, and I'm just going to get e to the 0, which is 1, times cosine of 0, which is also 1, so the answer to this problem is just 1. 25, I mean, this is kind of a little bit of a dumb problem. I shouldn't have assigned this. No one, I hope, would think to do the quotient rule in this situation. I mentioned in class that when you're learning the quotient rule, one of the most important things to learn is sort of when not to use the quotient rule. So this is a prime example of, dude, don't use the quotient rule here. Because even though it looks like a quotient, you can rewrite it as 4x to the 1/2 via exponent rules, and then the derivative is 2x to the negative 1/2. So yeah, that's just 2 over root x. So that's just how you do that problem. Okay, 27 is more of a traditional kind of quotient rule problem. Let's go. I don't think there's any kind of shortcut here. I think we just have to do it. So we take the derivative. What do we get? Well, the derivative of the top, which is going to be negative 2x minus 2 times the bottom, x squared minus 1. I'm kind of a little bit sad now because I think I've run out of room. Minus so derivative of the top, negative 2x minus 2, times the bottom, minus the top, so that's negative x squared minus 2x plus 3, times the derivative of the bottom, which is 2x. All over the bottom squared. So I don't think there's any kind of like deep shortcut or anything to doing this problem. So maybe I'm just gonna take up more room here and just do it all out. Well, okay. If I multiply everything out, what happens? I'm gonna get negative 2x cubed plus 2x minus 2x squared plus 2. And then here, let's try to not mess this up, I'm going to get negative 2x cubed, but there's a minus here, so plus 2x cubed. And then, let's see, minus 4x squared, but there's a negative, so plus 4x squared. And then plus 6x, but there's a negative, so minus 6x. All over x squared minus 1 squared. So this, hopefully something happens. Let's see. The 2x cubes cancel. I'm not so sure that I'm doing this problem right, but I probably am. So I have 2x squared on 2x squared and minus 4x plus 2 over x squared minus 1 quantity squared. And this, I'm not sure if there's really anything we can do. I guess I can factor out a 2, x squared minus 2x plus 1. Oh, I can do some things because that 2x squared minus 4x plus, yeah. So that's actually just x minus 1 squared. Oh boy. So this is really like 2 x minus 1 squared, but of course x squared minus 1 is x minus 1 x plus 1. So that's x minus 1 squared x plus 1 squared. So I guess the final answer to this problem is 2 over x plus 1 squared. Alright, that seems pretty good. Could I have done a better job here? Aha! I see that they have now tricked me. This problem tricked me and I fell for their sort of stinky trick, which is, had I been a little bit more on the ball here, I would have factored out a negative from the top, which would have given me negative x squared plus 2x minus 3 over x squared minus 1. And then I would have realized that that numerator factors as negative x plus 3 x minus 1 over x squared minus 1 is x minus 1 x plus 1. In other words, I could have just taken out an x minus 1 from the very beginning, and it would have been a lot less work for me to just differentiate negative x plus 3 over x plus 1. In fact, okay, this is getting to be some bad board management here. So let me draw a horizontal line. I stand by this answer, I think, of 2 over x plus 1 squared, which I got by just mindlessly doing the chain rule. But, let me now change my mind about doing number 51. and I guess I'll do it like over here or something. So what is the best way to proceed from here? I might even do polynomial long division. What is negative x plus 3 over x plus 1? Well, it's negative x plus 3 divided by x plus 1, which is going to go in negative 1 times, and that gives me negative x minus 1, and the answer is 3 minus negative 1 is 4. In other words, what is this function really? This function really is, after pulling a negative out of the numerator, factoring the numerator, canceling out an x minus 1, and doing polynomial long division, this entire function is really just negative 1 plus 4 over x plus 1. And, is that even true? Sorry, negative x minus 1. No, there's a little mistake here, because that should be negative x minus 3, I see. Oops. I made a little algebra mistake, so that's minus 3. So, therefore, negative 3 minus negative 1 is negative 2. Okay, so there we go. It's negative 1 over minus 2 x plus 1. Okay, so what did I just do? I just did a whole bunch of pre-calc, and now, maybe I'll switch to yet another color like purple. How do I differentiate this function, negative 1 minus 2 over x plus 1? Well, this itself can be thought of as negative 1 minus 2 times x plus 1 to the negative 1. And therefore, when I go to differentiate this, now this takes about 1 second. What is the derivative of this function? Well, the derivative of negative 1 is 0, and I get negative 2 times the derivative of x plus 1 to the negative 1 is negative 1 x plus 1 to the negative 2. And that's how I end up with 2 over x plus 1 squared. Alright, so that was an example of, you can either just mindlessly do the quotient rule as I did, or you can factor first. I don't know what they actually intended there. Okay, we push on. 45. This is just an easy problem. In fact, you might even say, where is the product rule, where's the quotient rule here? The only reason this is sitting here in the product rule, quotient rule section is because it's only now that we have learned the quotient rule that we know how to differentiate tan. So I'm not gonna reprove that or anything, because we did that in class, and you can see it done in the book, or you can just do it yourself using the quotient rule, write tan as sine over cosine. So what is the derivative of negative e to the x plus tan x? Well, it's the derivative of e to the x is e to the x. So this is negative e to the x plus, what's the derivative of tan? Secant squared. So that's just that whole problem just done. If you just know the derivative of tan. And down here is kind of more of the same. So I'm going to rewrite this problem as the fourth root of t is t to the 1/4. And okay, here it is. So how do I differentiate this? Just one piece at a time. The derivative of t to the 1/4 is 1/4 t to the negative 3/4. And what is the derivative of secant? Well, we just proved it at the beginning of this video that it's secant t tan t. So there you go. That's just this whole problem. It's 1/4 t to the 3/4 plus 8 secant t tan t. Okay, so wait, what have I done here? I did 17, 19, 25, 27 took a long time, sorry about that, 45, 47. So let's do 51 right now and 55. Then I'll pause the video. 51 was negative cosecant x minus sine x. Cosecant x minus sine x. Okay, so this is also just kind of like a one-line problem or something, if you already know things. So negative, what is the derivative of cosecant? Answer, it is negative cosecant cotan. Alright, so I just kind of know that, and I guess you should too. And what's the derivative of sine? It's cosine, so that's minus cosine. So that was the only really thing you needed to do there. Answer to this problem, cosecant x cotan x minus cosine x, done. And finally, 55 seems to be just a little bit of a drag. They basically just want me to do two product rule problems. So let's see if I can squeeze this in here. Maybe I even want to plan. Yeah, let's do like this. So now we have all the space we need. So what is dy dx? It is doing the product rule on 2x sine x. Well, it's the derivative of the first, so 2 times the second, sine, plus the first, 2x, times the derivative of sine, which is cosine. So derivative of the first times the second, plus the first times the derivative of the second. And then plus, now I also have to do the product rule on x squared e to the x. Derivative of the first times the second, plus the first times the derivative of the second, which is just e to the x. And so maybe I'll just stop there. So, okay, that was 51, 55, so there are 4 more problems. Be back in a minute to do those. Okay, here we go. Number 72 gives you a function, f(x) equals e to the x over x plus 4, and asks for the equation of the tangent line at the point 0, 1/4. If you plug in 0, you do get 1/4, so we're looking good. Alright, so I just need to differentiate this function. That's easily done with the quotient rule. So quotient rule says that you take the derivative of the top, which is e to the x, times the bottom, x plus 4, minus the top times the derivative of the bottom, which is just 1, all over the bottom squared. And so I just get this kind of gross formula. Well, okay, whatever. I'm not even going to simplify it because I'm about to just plug in 0 because it's specifically the derivative at 0 that I'm interested in. Well, e to the 0 is just 1, so you get 1 times 4 minus 1, so that's 4 minus 1 is 3, over, when you plug in 0 here, you get 16. So f prime of 0 is 3/16, assuming I did that correctly. I believe I did. Yeah, right? Yep. So, alright, great. What's the equation then of the tangent line? Well, it's just going to be y minus 1/4 equals 3/16 x. So that's it. Because it's just the line with slope 3/16 that goes through the point 0, 1/4. Okay, good. 73 is a similar question now, but the function that they give you is this function 8 over x squared plus 4, and they give you a little graph. This actually, graph has a name. This is the Witch of Maria Agnesi, and this is something that came up extremely briefly in Pre-Calc C when we were doing parametric equations. And, okay, you know, famous 17th century female Italian mathematician, Maria Agnesi, who studied these curves. Okay, let's go. Basically, I just need to take the derivative of this. Alright, there's a couple ways to do this, actually. I think what I would really do is use the reciprocal rule here. You can also use the quotient rule, but the reciprocal rule is somehow just actually more straightforward. What does the reciprocal rule say? It says it's going to be, well, first of all, I pull out the 8. So it's going to be 8 times the opposite of the derivative of the bottom, so negative 2x, over the bottom squared. And, you know, there we go. That's just the derivative. If you use the quotient rule instead, you're going to get the same thing as I got, but there'll just be some more steps and some more things will turn out to be 0, because, right, it's kind of like the derivative of the top times the bottom. Well, that just goes away. Minus the top times the derivative of the bottom. So you get the same thing that way. Okay, well, great. I have differentiated this function. Now what? Now I want to plug in 2. So let's do that. So if you plug in 2, what do you get? Well, on the top you're going to get negative 32, and on the bottom you will get 2 squared is 4, 4 plus 4 is 8, squared is 64. And so it seems that the slope of this line is negative 1/2. And that looks just very reasonable based on this picture that I've drawn here, and that the slope of this line would be negative 1/2. So therefore, our goal is to write the equation of the tangent line. Let's do it. What do we get then? It's y minus 1 equals negative 1/2 x minus 2. Okay, great. That was 73. 2 problems to go on this homework. This homework was very chill, actually. So 80 says, where does the function f of x equals e to the x sine x on the interval 0 pi have a horizontal tangent? Okay, well, I'm going to have a horizontal tangent line when the derivative is 0. So let's just find where the derivative is 0. So this is a calculus problem, kind of. What is the derivative of this function? Let's do it. I have to use the product rule. So the derivative of the first times the second plus the first times the derivative of the second, which is cosine. And okay, that took about 1 second. That is the derivative of this function. Now I have a pre-calculus problem on my hands, which is let's set this function equal to 0 to see when the derivative is 0. And now I just have to solve this. So okay, when is e to the x times sine x plus cosine x equal to 0? Well, okay, it's going to be true when either of these is 0, but e to the x is never 0, so that's just like not going to happen. When is sine x plus cosine x 0? Well, that's just when sine and cosine, are opposites of each other. Alright, personally, on the interval 0 pi, I can just tell you without even thinking that happens at 3 pi over 4. Because that's just where, at pi over 4, sine and cosine are the same. At 3 pi over 4, they're opposites of each other. At 5 pi over 4, they're back to being the same again. And over here, they're opposites of each other. So specifically, if I'm only looking at the interval 0 pi, which is what the problem told me, then the answer is just 3 pi over 4. I guess if you wanted to do this something else, you could divide by cosine, and you could write this as tan x equals negative 1. Perhaps that makes you feel better or something, but either way, at some point you need to just go to your knowledge of the unit circle, because when is tan negative 1? Well, it's at 3 pi over 4. So however you do it, the answer is 3 pi over 4. So summarizing, the derivative of 3 pi over 4 is 0. Just plug it in and check. So f has a horizontal tangent at x equals 3 pi over 4. Okay, that was number 80. Last problem, number 81, and I actually don't think that I can squeeze this problem into this space, so I think I'll do a quick erasing, just so I have the whole board to work with here, and yeah. Right, so find equations of the tangent lines to the graph of f of x equals x plus 1 over x minus 1 that are parallel to the line 2y plus x equals 6. Whew. Okay, well, first of all, this line 2x plus y equals 6 can be rewritten as, 2y equals negative x plus 6 and y equals negative 1/2 x plus 3. So the slope of this line is negative 1/2. And so when they tell me that my tangent line should be parallel to this line, they might as well just be telling me that my tangent line should have slope negative 1/2. So, okay, maybe I should graph this function first. That seems like a thing to do. Well, fortunately, this is a rational function, and I am an expert on that. what is there to say about this rational function? Well, okay, you know, we know everything, right? Vertical asymptote at x equals 1. There's going to be a root at x equals -1. I can make a sign chart that's -1, 1. It's going to be positive, negative, positive. It's quadratic-y. Is there anything even else to say? Yeah, I can do polynomial long division even. And I can write this as x plus 1 divided by x minus 1, which goes in, of course, 1 time. So it's x minus 1, 1 minus -1 is 2. So even another way of expressing this function is 1 plus 2 over x minus 1. Yeah. Okay. And, okay, I'm now realizing that I may have said something kind of weird earlier in the video. Technically speaking, we don't know the chain rule yet, as of the time that this homework was being done by you. So, yeah, so what you all probably did, well, okay, let's graph this function first. That was a little bit of pre-calc I did. So what does the function look like? Well, I guess I'll make a picture of it over here. It's a rational function. There's a root at -1. There is a horizontal asymptote of y equals 1. When I plug in 0, I get -1. When I get to 1, there's a vertical asymptote. And so, following my sign chart, I see that this function is positive until -1. The end behavior is 1 in both directions, and as I get very... Something went wrong. What have I done? 1, -1, boom, 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 positive, and then... sorry, I confused myself for a second here. There is a root... And then, what? Oh, yeah, it's nothing. Everything's fine. Positive until -1, then negative between -1 and 1. So down there or something like that. And then positive thereafter. Okay, I mean, that's the way to do it looking at the first version, but it's kind of even more obvious if I look at this version, right? Because what is this function? It's just the 1 over x function. Stretched out by a factor of 2, moved 1 to the right, and moved up 1. So, okay, there it is. Although I'm now sort of like not happy about how pretty my picture is, but okay. There we go. Okay, great. Well, and I guess, yeah. So down, left 2, down 1, left 1, down 2. So this will be, I mean, I don't know if we kind of care about this, but if you do want this to be accurate, you could plug in some numbers. Like if you plug in 2 and 3, when you plug in 2, I guess you're going to get 3. Yeah. And when you plug in 3, you're going to get 2. So, all right, you know, there it is. Okay. So, great, I did some pre-calc. What am I supposed to be doing again? Finding equations of the tangent lines to the graph of this function that have slope -1/2. Well, I can just eyeball this right now, that somewhere around here or so, there is going to be a line with slope -1/2, and there's also going to be a line with slope -1/2 around here or so. So there just are going to be 2 lines with slope -1/2, because my slope starts out pretty much 0 and becomes like -infinity, and here my slope starts out like -infinity and becomes pretty much 0. So there are going to be 2 places where the slope is -1/2. All I have to do is find them. Okay, well, I'm going to now take the derivative. And I guess what you all probably did was just use the quotient rule, so maybe I'll just use the quotient rule also. What's the quotient rule say? Derivative of the top, which is 1, times the bottom minus the top, which is x plus 1, times the derivative of the bottom, which is 1, all over bottom squared. Okay, if you do that, what do you get? you get x minus 1 minus x, so it's really like minus 1 minus 1, so this is negative 2 over x minus 1 squared. So that was actually quite fast to take that derivative. The alternative thing you could do is you could take the derivative using this version, because the derivative of 1 is 0, and then what you end up with is 2 times, what's the derivative of 1 over x minus 1? Well, it's the negative of the derivative of x minus 1, so negative 1, over x minus 1 squared. So I just used the reciprocal rule there, and I got the exact same thing. And then the even other thing you could do is you could think of this function as 1 plus 2 times x minus 1 to the negative 1. And then you could use the chain rule. So what you didn't know then, but you do know now, chain rule says the derivative of this is derivative of 1 is 0. This is negative 2 x minus 1 to the negative 2 back inside for the derivative of x minus 1, but that's just 1. And so you get the same thing. Okay, the point of all this is that now I can tell you precisely when, I have a formula for the derivative basically. The derivative of this function is negative 2 over x minus 1 squared. And I want to know when are the slopes of the tangent lines negative a half. In other words, when is the derivative equal to negative a half? So I set this derivative equal to negative a half, and well, what do I get? Cross multiply, negatives cancel, 4 equals x minus 1 squared. Take the square root of both sides, so that's going to happen when x minus 1 is plus or minus 2. So that's going to happen when x is 1 plus or minus 2. In other words, at 3 and negative 1. Alright, so what have I just learned? I've just learned, I kind of suspected this already, that in fact it's this point here, 3 comma, if you plug in 3, you get 4 over 2. So that really is 3 comma 2, that point, is one of the points where the slope of the tangent line is negative a half, and the other point where the slope of the tangent line is negative a half is when x is negative 1, and when you plug in negative 1 here, you get 0. So these are the two lines. That line has slope negative 1/2, and that line has slope negative 1/2. And the final thing to do is to write the equations of those lines. So that one is, the first one is going to be y minus 2 equals negative 1/2 x minus 3. And the next one will be y equals negative 1/2 x plus 1. Okay, that was 81. This was the homework on the product and quotient rule. It's actually Thursday night right now, and I made this homework due, or I made you hand it in rather, yesterday. So I'm sort of behind on this, but I will post this video, and hopefully some of you can get some help on this. Okay, bye.